All right, here we go, guys. Do you want to say hello?
Hi, Bella.
Hey, Belita.
Oh, that was Michael Jackson. All right. Well, you know what I mean. All right, guys. So it says, let's chat a little bit about the difference between rectangular coordinates and polar coordinates. Do you guys remember anything from last year?
I remember what you told us yesterday.
Yeah.
Okay. So if I have a coordinate, this is called rectangular coordinate. Sometimes it's also another word. Do you remember that other word?
You said Cartesian.
Cartesian. Perfect. So both of them mean the same thing. That I have a plane, and it's x comma y. If it was three-dimensional, then you would say x comma y comma z. So there it is, x comma y, and I can duplicate that same coordinate in polar coordinate. So here's that same coordinate. The only difference is I have, for this one, it's r comma theta, where r stands for the radius from the origin, and theta is the angle that you are, or the angle, right? Does that make sense?
Yeah.
So let me go ahead and draw this distance. That is the r. Now, usually we don't write like that blue line there, and we just say, oh, 5 comma pi over 4. But there it is. And this is your theta. Cool or not cool? All right, now there's relationships here. So they're very easy to get those relationships. Because it's in the origin, because it comes from the origin, you can say x squared plus y squared equals r squared. Let's see, if you want to go from polar to rectangular, you can say that the x value is nothing more than r cosine theta. The y value is nothing more than r sine theta. And let's see, what else? That's an x, that's a y. Tan theta is equal to y over x. So these are the major four. And if you know that, you can go back and forth. Does that make sense, guys? Okay. We still okay? All right, let's go to the next one, the example here. So it says, find the rectangular coordinates for the points with the given polar coordinates. All right, so first let's do a visual. Oh, by the way, r can be negative. If r is negative, you just go backwards, quote unquote. All right, so let's see. This one says 4 comma pi over 2. So 4 comma pi over 2 is going to look like right here. Pi over 2. And the distance is from the origin up to here. So what coordinate is that? 4 comma 0 in rectangular. Does that make sense?
Wasn't it 0, 4?
No, it's, oh yeah, yes. No, no, that's so funny. I know calculus. I don't even know the x, y coordinate here. Yeah, 0, 4, you're right. All right, ready for the next one?
No.
No?
Oh,
All right.
yes, we're ready.
All right, so be careful with this one. The thing that I would do first is the angle this time. So this is pi. But because of that -3, I'm going to go backwards. So I'm going to be right here. What coordinate is that? 3, 0. Good job. Cool or not cool? Cool. Let's go to the next one. And I'm going to exaggerate it. So here's my x and y axis. So 16, 5 pi over 6. So 5 pi over 6 is like somewhere like right there. And I'm going to say that distance here, I'm going to say that distance is 16 there. So I want that x and y coordinate. So here's how I'm going to do it. I'm going to go, let's see, what am I going to do? X equals 16 cosine of 5 pi over 6. So 16, and do you remember what cosine of 5 pi over 6 is? Perfect. So -8 square root of 3. So -8 square root of 3. And then sine, the y value is 16 sine 5 pi over 6. So that is 16 times a half. So 8. So there it is. Negative 8 square root of 3, comma 8. And of course, I didn't draw it to scale, but it's, you know. We still okay? All right, the last one here. Negative pi over 4. Well, I'm going to do this negative pi over 4 first. That would have been down here. But because I have that negative square root of 2, that puts me in what quadrant? Quadrant 2. So again, like the last time, x equals negative square root of 2 times cosine of negative pi over 4. It's going to give me a negative value. It better. Negative square root of 2 times cosine of negative pi over 4 is square root of 2 over 2. So you get negative 1. Negative square root of 2 times square root of 2 is 2. And 2 divided by 2 is 1. Same thing with the y value. Negative square root of 2 times sine of negative pi over 4. So that's negative square root of 2. And then sine of negative pi over 4, that's going to be a negative square root of 2 over 2. So negative times the negative is a positive. So that's going to be 1. And there it is. Negative 1, 1. How do we feel, guys? All right. Hopefully you remember these are actually the same notes as last year, but I did add to it. I added another page and a half or 2 pages. All right, it says find 2 different sets of polar coordinates for the points with the given rectangular coordinates. Okay, so here we go. So that's a rectangular coordinate. So 1, 0 is right here. And they want me to give 2 different polar. So in polar, I could say, again, 1, 0. I could also say 1, comma 2 pi. I could also say 1, comma 4 pi. What if I wanted a negative 1? Negative 1 pi. Because pi would have put me in the negative x-axis, but the negative 1 would have brought me back to 1. Does that make sense, guys? Those are all different. I should have put more than 2. Well, that's more than 2. That's 4 of them right there. Those are all the same. All right, let's go to the next one. Negative 3, 3. It's obvious that you can tell, I hope that you can tell, that this angle here is 3 pi over 4. And you can tell that because the x and y coordinates are the same. So all you need is this radius, and we get that really quick by just going negative 3 squared plus 3 squared and the square root of that. So 9 plus 9 is 18. And 3 square root of 2. So here we go. 3 square root of 2. Oh, someone tapped on the little bell. 3 square root of 2, comma 3 pi over 4. And I'm gonna do a move like what they did here for this one. I'm gonna say negative 3 square root of 2, comma negative pi over 4. And those are 2 of them right there. Let me change the colors so we can, because it's getting pretty packed. What's up, Yukana? But we got it though, right? Now we just need practice. Okay. So this one here, 0, negative 4. So 0, negative 4 is down here. I'll do it in blue. So let's see, we can say 4, comma 3 pi over 2. Give me another one, Viyakana. Make it a negative 4. Pi over 2.
Wait, how'd you get 4 to be the x value?
Well, it's not the x value. It's an r.
Oh, yeah, sorry.
Yeah, we're in polar. You know what I mean?
Yep. That's like the length.
That's the length from the origin to whatever, yeah, where the coordinate is. And I don't know, maybe we're being silly here, or maybe I just didn't notice. It says negative 1, 1, but we had already done one that had negative 1, 1, hadn't we?
Yeah.
I thought we did.
It was the answer to the fourth one on the toilet.
Oh, yeah.
Negative 1, 1. So there it is. So negative 1, 1 is the same thing as saying negative square root of 2 comma negative pi over 4. That's one of them. Or you can say square root of 2 comma 3 pi over 4. And those are just two of infinitely many answers. You don't have to stop at 3 pi over 4. You can do another revolution on top of that. How do we feel, guys? Okay. Let's keep going. It says graph all points in the plane that satisfy the given polar equation. So these are simple ones. And don't worry, on the next session, we're going to talk about harder ones, lemma-cons and all that. So here we go. It just says r equals 2. They don't give me any theta. So because they don't give me any theta, they're talking about all thetas. So if r equals 2, that just means a circle with radius what? Yep, that's all it means. So you go to r equals 2, negative 2, negative 2, 2, and you just make your circle. And there it is, r equals 2. Trick question on letter B. It says r equals negative 2. Well, it's the same. It's the same. The only difference is you would actually, if you were to start from t equals 0 to t equals 2 pi, it would go backwards. And you'll see what I mean in a little bit when I take out the calculator for that. You're still okay, guys? Okay, now notice on letter C, they do not give me a what? A radius. So that means that r can be any value. It's just a line. Go to pi over 6. Pi over 6 is right here. And then it's just that line going forever and this line going forever because r can be negative, right? If r is all real numbers, now, okay, we got to be careful for this. If they tell you that r is less than 0, then it would just be the line on the bottom. Okay. Yeah.
In quadrant 3, right?
In quadrant 3, yeah. And there it is, guys. How do we feel?
Okay.
All right. So polar rectangular convergent formulas, there's 4 major ones. And we just talked about it in the front of the page. So here are the 4 major ones. X squared plus y squared equals r squared. Why is that one of them? Well, it's easy to see because remember, the r starts at the origin. So just by looking at that, well, yeah, x squared plus y squared equals r squared all the time. And then from there, you can get the other two as well. That x has to equal r cosine theta, y has to equal r sine theta, and tan theta equals y over x. Guys, none of these formulas, none of them, they are all derived from literally this one right here, from this, right? SOHCAHTOA. SOHCAHTOA. Look, sine. Sine theta is equal to opposite y over r times r, y equals r sine theta. Same thing with the x. Cosine theta equals adjacent over hypotenuse, x over r. So times r, x equals r cosine theta. So all of these formulas can be derived. I don't want you to think that we just came up with them. Are we okay there, guys? Okay, so these are the 4 major formulas. From this, you can pretty much transform any polar to rectangular, any rectangular to polar. Of course, some are more difficult than others, but this is the main gist. Cool, guys? All right, let's keep going. All right. It says, use the polar rectangular convergent formulas to show that the polar graph r equals 4 sine theta is a circle. And yes, we'll go over this in more detail, so don't worry. So I have r equals 4 sine theta. I'm trying to convert this into x and y, right? So what I'm going to do, we're going to do a hack. And so I'm looking at these right here, and I'm like, man, what can I do? Well, we're going to multiply both sides by r. This times r, whatever you do to one side, you got to do to the other. So now I have this, r squared equals 4r sine theta. Then I look at my little formulas here, and I see that r sine theta is y. And I see that r squared is nothing more than what? So there we go. So I'm gonna write x squared plus y squared on the left, because that's what r squared is, equals 4y. Now they want me to prove that it's a circle. Hopefully you remember, and if you don't, it's okay, that all circles look more or less like this. X minus, they look like this. X minus X naught, well, let's use H and K for the center. X minus H close it squared over R squared plus Y minus K close it squared over R squared equals 1. I kind of wanted to put all that in parentheses. You know what? Let me do it better. Giant parenthesis X minus H over R squared plus Y minus K over R squared equals 1. All circles look like that. So we need to make it look like that. Or something similar to it. Cool? Here we go. I'm going to move the 4y to the left. X squared plus y squared minus 4y equals 0. Now I'm going to complete the square for the y's. So I'm going to write x squared plus y squared minus 4y. 4 divided by 2 is 2, and 2 squared is 4. Now that's magic. I can't just magically add anything to one side, so whatever I do to one, I do to the other side. So now I take this 3, and I'm going to write x squared plus parenthesis y minus 2, close it, squared equals 4. We're almost done, guys. I'm going to divide everything by 4.
I have a question.
Yes.
Why did you complete the square instead of like just factoring it out?
Oh, there's nothing I can factor out. I mean, I guess you could have factored out a y when this one's not there. But then I would have had y minus 4, and then what do I do with that y? Like, it's not looking like this. You know what I mean? I need it to look like that. Does that make sense? So now look, I have x over 2 squared plus y minus 2 over 2 squared equals 1. There it is. That's the equation of a circle. What's my radius? 2. Sometimes they call this general form. I can see some of you guys looking like, what? I don't remember that, Chav. Sometimes they call that general form.
Wait, okay, so
It was like a minute.
Okay.
why couldn't we just leave it with them over 4?
You could have.
Oh, I see, you put the 2 inside the parentheses.
Yeah.
Oh, okay.
You could have left it. You could have left it x squared over 4 plus y minus 2 squared over 4 equals 1. You could have left it like here. You could have left it like here. You could have left it even like this one. X squared minus y minus 2 squared equals 4. You could have left it any of these 3 that are boxed.
Okay. That makes sense. Thank you.
Cool? Is it a circle? Yes. It's definitely a circle. Where's the center at? 0, 2. What's my radius? 2. So this graph looks like centers at 0, 0, 2. Did I say that? Yeah. Centers at 0, 2. And it looks like cool. In a little bit, we'll play with the calculator so you can see them. All right, here we go. Now we got some you try stuff. We'll do it together, don't worry. It says plot each point with the given polar coordinates and find the corresponding rectangular coordinates. Okay, so here's my grid. This one is going to exaggerate quadrant 1 because square root of 2 and power 4. So here's my radius, here's my angle, and they want me to write that in rectangular coordinates. So let's see, my x value is square root of 2 cosine of pi over 4. And my y value is square root of 2 times sine of pi over 4. So they're both going to be the same thing. So square root of 2 times square root of 2 over 2. So it looks like it's 1, 1. Excuse me. You okay so far? All right, guys. This one here, 1, 0. It says, again, same thing. So this is probably one of the unique ones. Oh, this is one of the unique ones. 1, 0 in polar is the same as 1, 0 in rectangular. Because
You said when the
there might be, well, let's see. That's probably,
theta 0.
yeah, theta is 0, and my radius is 1. So in polar and Cartesian, 1, comma 0. So that's probably, it's the only one that ever occurs like that. Cool? What do you think, Lanford? I think I gave one like that on the activity. I also gave one to see if you really understand the concept. You'll see which one when we get there, when you guys get there. 0 pi over 2. The fact that you see r is 0, immediately you're going to be where? At the origin. It doesn't matter what the angle is. If your r is 0, you're at the origin. So 0, 0. And then letter D is similar to letter A. Instead of quadrant 1, you're going to be in quadrant 3. And what coordinate is that going to be? Yep. How are we feeling, guys? We feeling okay? Ready for the next? Plot each point with the given rectangular coordinates and find 2 sets of corresponding polar coordinates. All right, so let me exaggerate quadrant 2, negative 1, 1. This is my r. So r has to obviously be square root of 2. Negative 1 squared plus 1 squared is 2, so square root of 2. And my theta, yeah, that's one of them. There's so many. Did they want 2 of them? Yeah, they want 2 of them. So square root of 2, comma 3 pi over 4. What else? I could say negative square root of 2, comma. Yep. You okay? Sorry. Hey, Mazuka, there's bugs falling. All right, here we go. This one, 1 negative square root of 3. What quadrant is that? 4. So I'm going to exaggerate quadrant 4. So 1 negative square root of 3. I'm going to say that. That's a 3 there. Chavez, how are you going to calculate r? Simple. Quadratic formula. 1 squared is 1. Square root of 3 squared. The reason I'm not saying negative is because it doesn't matter because I'm squaring it. Yeah, look, isn't it? Don't I just have a right triangle there? I mean, did I say quadratic? I meant to say Pythagorean. Pythagorean theorem. Yeah, you're right. I don't know what's going on, and that's that I had a shot.
We're gonna start singing. No, sir, you need sleep.
I don't need sleep. So here we go. So sorry, Mazuka. We meant to say quadratic formula.
You might have said it.
I meant to say Pythagorean theorem. Look, I said it again. Oh man, I didn't need to edit that. No, I'm just gonna upload the video. Don't give me a thumbs down, guys.
You might have said it and then just like I heard quadratic.
No, I think I did say quadratic. I meant to say Pythagorean theorem. It's a right triangle, Pythagorean theorem. 1 squared is 1. Square root of 3 squared is 3. 3 plus 1 is 4. So my radius has to be Yeah. R equals the square root of 1 squared plus a negative square root of 3 squared. So R equals the square root of 4, which is 2. The theta is equal to arctan of negative square root of 3. Do you guys know where I got that from? Just from tan theta equals y over x, right? What do you mean?
Oh, yes.
Yeah, like, yeah, look, just
Okay, yes.
opposite tan theta is y over x, so theta equals arctan of y over x. That's how you always get it. Oh, there's still bugs falling down? Oh, man.
He knows that you're gone now.
So let's think about it. On the unit circle, where is plus it's in quadrant 4, you already know that. So on the unit circle in quadrant 4, where is the y value? Negative square root of 3 over 2, and the x value a positive half. Yeah, 5 power. Did you say 5 power over 3? So there it is, guys. So 2 comma 5 power over 3. Give me another answer. Give me one with a negative 2.
Negative 2, negative 2 pi over 3.
Positive 2 pi over 3.
Times, yeah.
There you go, guys. Let's keep going. Letter C, 0, 3. Oops. 0, 3 is up here. That angle is pi over 2. So in polar, this is 3 comma pi over 2. Give me another answer, but with a negative 3.
Negative 3, 3 pi over 2.
Yeah. Negative 1, 0. Give me an answer, Villacana. 1 comma.
1 comma pi.
Yes. Now give me one with a negative.
Negative 1.
Yes.
Okay.
Remember we said earlier this is one of the unique ones?
Oh, yeah.
0, negative, yeah. Good job. All right. Let's go to the next page. Hey, what was up with that side?
No.
Just because Mazuka's not here, you check
I'm
up?
trying to make up for it.
Yeah.
I'm trying to make up.
Don't worry, Mazuka. We're not talking smack.
When it's like audibly recorded.
So we'll know tomorrow if she really watched the video or not.
We will.
Because she'll either come in and be like, hey, what's up, guys? Let's do blah, blah, blah. Or she'll be like, why are you guys talking smack? So this is how we're going to find out, Mazuka, if you're watch this video. All right, here we go. So I have, what do they want? What do they want me to do?
No.
Oh, we need to find a normal equation.
Yeah, well, don't call it normal. Cartesian equation in terms of x and y.
Yeah.
So here we go. What I would do first, guys, because we don't have the experience yet to like just tackle it immediately, what I would do first, have everything in terms of sine and cosine. Why? Because that's all we know. We know everything. Look at your general forms or your formulas. All these formulas that we have are just in terms of cosine and sine, right? So let's go ahead and do that. So I'm going to write R equals 4 over sine theta. And then we look for patterns. You ready? I'm going to multiply by sine theta both sides. R. Yep, there you go. R sine theta equals 4. And then I see that R sine theta is equal to y. So there it is. So if you were to put this in your calculator, it would just draw a horizontal line. Y equals 4. There it is. Very cool. What do you think, Viacana? All right, let's look at this one. So I have r cosine theta plus r sine theta equals 1.
X plus Y.
Yeah, there it is. You saw that's an x, you saw that's a y. X plus y equals 1. You can actually leave it like that, but if you want it to look more formal, y equals negative x plus 1. There it is. So if you were to put this into your calculator, it would look like a linear line. Let's go to the next one. I'm going to multiply it by the denominator to get rid of it. So times sine theta minus 2 cosine theta. Whatever you do to one side, you do to the other. Sine theta minus 2 cosine theta. So here's what we have. R parentheses sine theta minus 2 cosine theta equals 5. We're going to distribute that R. R sine theta minus 2r cosine theta equals 5. And then what do we notice? Y minus 2x equals 5. Move the perfect. There you go. We're still doing all right? All right, cosine squared equals sine squared. No, I'm just putting the properties. No, well, I mean, I guess we could, but that says cosine squared. Okay, I got an idea. So cosine theta is equal to x over r, and sine theta is equal to y over r. So we're going to go x over r squared equals y over r squared. I just replaced the cosine and the sine. We're still okay? So now when I square it, x squared over r squared equals y squared over r squared. Now you can cross multiply if you want, but I see the r squares canceling out. Plus you have r squared on the bottom, so that means, what does that mean? X squared equals y squared. You can actually leave it like that if you wanted to. If you want to solve for y, you could say y equals, but you better say what in the front. I can say y equals, but I better say what. I can't say y equals x. That's wrong.
Y equals square root.
No. Oh man, guys.
I don't know.
Well, if I can't write y equals x, then what can I write? What's the square root of 9? It's not just 3.
Positive, negative.
There you go. Plus minus 3. Oh, plus minus x. And that's it. So you just have an x. It's just a solution curve on this one. Ready for the last one here? Multiply the right side by r, multiply the left side by r. There's going to be a circle. So you have r squared equals 8r sine theta. R squared is equal to x squared plus y squared. R sine theta is equal to y. Move it to the left. We're going to complete the square like we did the last time. x squared plus y squared minus 8y equals 0. X squared plus y squared minus 8y. 8 divided by 2 is 4, and 4 squared is 16. Whatever you do to one side, do to the other. X squared plus parenthesis y minus 4 close it squared equals 16. You can leave it like that. Where's the center? What shape is this? A circle? Where's the center? 0, 4. What's the radius? 4. We got it, guys? All right, you have an activity. Mazuka, let us know if you understood everything. I think everything's pretty straightforward. We'll find out if you watch this video. And that's it, guys. All right, talk to you guys later. Bye.